Hello, everyone. Welcome to 3.4 exponential and logarithmic equations. So with these first two here, we don't need to use logarithms, okay? I'll show you how we're going to do that without logarithms now. So in problems like these, we can get a common base and then solve. So how can we get a common base between the 16 and 4? Well, you can get them to be both 4, right? So 4 to 4 squared, right? Get you 16. So 4 squared to the power of x plus 3 equals 4 to the power of 4x plus 7. And power to a power we multiply, so it's going to be 4 to the power of 2x plus 6 equals 4 to the power of 4x plus 7. Now that we have the same bases, we can just set the exponents equal to each other. So 2x plus 6 equals 4x plus 7. Subtract 2, subtract 2, subtract 7, subtract 7. Negative 1 equals 2x divided by 2, divided by 2. Negative 1 half equals x. That's the first one. Now, this other one here is a little bit trickier, okay? So there's two things I'm going to need to do, okay? So if I say without logarithms, then clearly I can get the same basis somehow. One thing that's sticking out is that the number is bigger over here than the denominator, and then the denominator is bigger over here. So I'm going to need to flip one of these if I'm going to do that. So I'm going to flip the left side. I'm going to switch colors here. Let's go red. So 3 over 2. Remember, when we flip, the sign flips in the exponent. So I'm going to put parentheses around that x minus 5. And then on the right side, how am I going to get 3 over 2? Well, 3 squared is 9, right? And 2 squared is 4. So if I just make this 3 over 2 to the power of 2, and now we have the same basis. Look at that. Power to power we multiply, so you're going to get 6x over 4 equals negative x plus 5. We're going to isolate x. Get 5 equals, if you're adding x to that, that's going to be 10x over 4. Multiply both sides by 4 over 10 to isolate, and you're going to get a final answer of 20 over 10, which is going to be 2. So x is equal to 2. So these down here are logarithmic equations. So with these, I would recommend getting the logarithm alone and then changing it to exponential form. That's usually what's going to have to happen with these. So this first one, logarithms aren't alone. We need to divide by negative 3 first. Ln x equals 8. Change it to exponential form. You're going to get e to the power of 8 equals x. Remember, change it from logarithm to exponential. It's important. You need to remember that for this section. E to the power of 8, you can throw that in your calculator. You also, I don't need to know that decimal. This is the most exact answer. Next, we subtract 4 first and then divide by negative 3 as well. So we get negative 3 log of 5x equals 12. Divide by negative 3, you're going to get log of 5x equals negative 4. Change the exponential form. 10 to the negative 4th equals 5x. Divide by 5. Divide by 5. And you will get 0.00002. All right. Next one, we got a little lucky, but also a little unlucky, in that we can go straight to putting in exponential form. Yay! So 3 to the power of 4 equals x squared minus 1. 3 to the power of 4, though, that's going to be about 81. And we subtract 81, subtract 81. You're going to get x squared minus 82. and then move the 82 over. 82 equals x squared, square root. X is equal to the plus or minus square root of 82. There are also equations where we're going to have to use some of our properties we learned in the last section. You see a plus there, so you know right away you can combine it into one logarithm and multiply. So log base 12 of x times 4, which is 4x, equals log base 12 of x plus 3. We like the ones that have log on both sides of the equation because we can just set what's inside our logarithm, in this case x plus 3, equal to 4x. Subtract x, we get 3 equals 3x. Divided by 3, x is equal to 1. Now we're back to solving exponential equations with unknowns in the exponents. These aren't as simple as the ones we did previously. These have to do a little bit of calculator work and logarithm rules. So I need to get the base and the exponent alone. That's the first thing you need to do with these problems, get the base and the exponent alone. We're doing that with 1.43 to the power of a equals 5.38. So now we can, whenever we get the base and the exponent alone, we can find the logarithm of both sides. Now, why would we do this? Because if we log both sides, I can use our exponent rules and bring the a up front, and now we can have a much easier time of finding the unknown in the exponent. And I'm going to divide both sides by log of 1.43. And a is going to be equal to whatever that is in your calculator, which is 4.705. I rounded to the nearest thousandth. That gives us a good understanding of what it is. Second one here. We have a base e. It's already by itself, so I'm going to ln both sides. Bring the exponent down front to plus 5w ln of e. We like these ln problems a little bit more because ln of e, as you hopefully remember, is 1. So that goes away. So you get 2 plus 5w equals ln of 12. Subtract 2, 5w equals ln of 12 minus 2. Divided by 5. Your answer is w equals ln 12 minus 2 all over 5. If you are putting that in your calculator, your answer would be 0.0969. And on to the next ones. And now another exponential one. So we log both sides. Log of 6 to the power of 2x plus 4 equals log of 5 to the power of negative x plus 1. Use your rules. So we're going to bring the 2x plus 4 down. And we're going to bring that negative x plus 1 down. This is a more complicated problem, unfortunately. So if we distribute that log of 6 to both terms and log of 5 to both those terms, we get 2x log of 6 plus log of 6 equals negative x log of 5 plus log of 5. I'm going to move all the ones with x on one side and non-x's on the other. So I'm going to move 2x log 6. If I add x log 5 to the other side, and then I'm moving this log 6 to the other side. Okay. So we have an x in both terms on the left, so I can factor out an x. Left with 2 log 6 plus log 5 equals log 5 minus log 6. If I divide everything by 2 log 6 plus log 5, that will get you your answer, which is just x equals negative 0.035. On to the next one. So right away I see a subtraction sign and I want to use my logarithm rule. So I'm going to do ln of 7x plus 3 over x plus 1 equals ln of 2x. So we have ln on both sides, so I can set what's here equal to each other. So 7x plus 3 equals x plus 1 equals 2x. I'm going to multiply both sides by x plus 1. It's going to be 7x plus 3 equals 2x times x plus 1. Because if I multiply both sides by x plus 1, this will cancel right there. That'll give me 7x plus 3 equals 2x squared plus 2x. Let's move the other terms over. 7x minus 3, giving us 2x squared minus 5x minus 3 equals 0. If you factor that AC method, a times c is negative 6. We'll replace negative 5 with negative 6x plus x minus 3. And factor. And get 2x out. Left with x minus 3. Take out a 1. And we'll get 2x plus 1. X minus 3. Two solutions of x is equal to negative 1/2 and 3. Our last problem here is a little twist to this one. So we get one logarithm, so ln 6y plus 2 over y plus 1. And the other side stays the same. And we have ln by itself, so we need to set what's here equal to each other, right? 6y plus 2 over y plus 1 is 2y minus 1. Multiply both sides by y plus 1. So you get a 6y plus 2 equals, I'm going to have to FOIL this, 2y minus 1 times y plus 1. If I FOIL, I'll get 2y squared plus y minus 1. I don't need parentheses around that anymore. Equals 6y plus 2. Let's move that 6y and 2 over. We can solve algebraically. 2y squared minus 5y minus 3. And AC method, so once again, negative 6y plus y. Oh, it worked out to be the same, that's weird. So it's going to get 2y, parentheses y minus 3, plus 1, y minus 3, giving us solutions of y equals negative 1/2 and 3. Now what's the issue with this one? If we put negative 1/2 into either one of these, we get a negative inside here, and that's bad, okay? Because we can't find the logarithm of a negative number. It's impossible. We went over that earlier. So the only one that works here is y equal to 3. Negative 1 is an extraneous solution, what we call, right? Where we algebraically it works, but we plug it back in, it doesn't. All right, appreciate watching, and we'll see you in class. Bye-bye now.